Now we're going to look at a worked example of multiple alleles, and the most common multiple alleles example is blood groups. So we're going to look at this because there are 3 possible alleles in blood groups. They are allele A, allele B, and allele O. Now you'll be wondering why on earth I have put a capital I. What's that all about? Well, I've used a capital I because that is the name of the gene, and there are 3 variants of the gene. The name of the gene, which you do not need to remember, is isohemagglutinogen. And that's why I've used a capital I. You do not need to remember that, but why not? So we've got 3 possible alleles. At any one time, each person can only have 2 of those options. So if you are blood group O, this allele happens to be recessive to both of the other alleles. So if you are blood group O, you only have one option. Both of your alleles have to be O. Now, if you are blood group A, you actually have 2 options. You could have both of your alleles allele A, or because A is dominant over O, you could be IA-IO. Both of these will result in a phenotype of blood group A. So remember, this is our phenotype, and these are our genotypes. So blood group B, you should be able to work out now. Because B is dominant over O, because O is recessive to B, so that always works in pairs like that. 2 B's together, or IB and IO. The interesting one for this is not only do we have multiple alleles, we also have some codominance going on, because you can get blood group AB, and that is because these 2 alleles are codominant. They both get expressed in the phenotype. There's only one way to be blood group AB, and that is to have one of each of the alleles. So these are all our possible genotypes to get our phenotypes here. So let's have a look at some interesting crosses between people with different blood groups. So let's take a male, and this is the symbol for a male, who is a blood group A. And let's say that he has the genotype of IA-IO. And he is married to a female with blood group O. She only has one option for her genotype, so it's IO-IO. And let's show what their gametes are in a Punnett Square and see what the possible options are for the blood groups of their children. So we'll pop mum's gametes up the top here. They're both going to be the same because she's only got one option of allele. But for dad, let's pop his down the side here. Half of his sperm will be carrying the A allele and half of them will be carrying the O allele. Now the children, when we fertilise the egg with the sperm, will be blood group A, blood group A, blood group O, or blood group O. So very much like their mum and dad. Okay. Let's have a look at something a little more controversial. Let's take dad with blood group A, and mum with blood group B. And let's see what they produce. We'll give them both a heterozygous genotype. Let's give them some children. Mum's alleles at the top here. Dad's down the side in circles because we are showing the examiner that we understand that they are gametes. Their first child's blood group is blood group AB. Their second child's blood group is blood group A. The third option for their child is blood group B, and the fourth option is blood group O. So 2 of the blood types that is possible for their children, this one and this one, are not the same as the parents. So you have to be a little bit careful to make sure you understand your genetics, because if you go home and find out you've got a different blood group from both of your parents, that does not mean that you are adopted. Okay. So you can now explore some different options, look at different types of blood groups that the parents could have, and have a look at what the options are for the children.